for D, we're going to look at permutations and combinations, okay? So if it's a permutation, it means the order matters, okay? I'm picking a group of objects, and the order that I place them in matters. So how many ways can you arrange the letters A, B, and C? Well, I could go in that order, A, B, C, or I could go A, C, B, or I could go B, A, C, or B, C, A, or I could start with C, C, A, B, or C, B, A. So 1, 2, 3, 4, 5, 6 different possibilities, okay? Now, with just those 3 letters, it's easy for me to kind of write those out, but if I get a larger group of objects, it's not practical to list out each probability. So, the number of permutations for an object is that number factorial. Okay, so here there were 3 letters, so that would be 3 factorial. Alright, and in case you don't remember, factorial means I take that number and I multiply then the next number lower all the way down until I get to 1. So 3 times 2 times 1 would be 6 possibilities. Okay, so example, there are 9 players on a baseball team. How many different batting orders are possible? Well, I have 9 different players, so 9 factorial, 9 times 8 times 7 times 6 times 5, on and on and on. Or your calculator can do that as well. So I'm going to show on a Casio just because I have the ability to show that on my computer screen. If you have a TI and aren't sure how to do this, just come see me during class and I can show you. It's pretty easy. Okay, so I want 9 factorial. So I'm going to hit the option button right here, and I need to go over, so that's F6, until I see probability. Alright, I want to pick F3. Alright, and that button right there is factorial. So if I want 9 factorial, I'm going to type 9, and then F1 will give me that factorial, and 9 factorial is 362,880. So out of those 9 different baseball players, I could come up with 362,880 different orders to put them in. Alright, what about if we take that same baseball team and, the baseball teams, you have to have subs. So there's actually 12 players on the team. How many ways can I choose 9 of them for a batting lineup? So I could have them in all different orders, and I have 3 subs. So I'm only picking 9 out of my 12. So this is the formula for a permutation. Alright, it would be n factorial. There are 12 objects, so 12 over 12 minus 9 factorial, because I'm picking 9 at a time. Alright, so you might be familiar with this notation, NPR, and when we did permutations and combinations previously, maybe in Algebra 2, we talked about 12 choose 9. I have 12 players, and I'm going to choose 9 of them. So that would be written like this: 12 choose 9, and the P is for the permutation. That can be done on your calculator as well. So here are the steps for that, okay? We already have that probability screen up, so the option, go over to probability. Okay, so if I'm going to do 12 choose 9, I have 12 objects, and I'm going to pick 9 of them. I want this NPR, so 12 choose 9, 12 people on my team, 9 of them in the batting order. There are 79,833,600 different ways that we could list out all of those people in a batting order. All right. Next thing is combinations. So in a combination, the order does not matter. So when I was picking those players for my batting lineup, like, it's different if you're batting first versus if you're batting fifth. Like, it makes a difference what order you put the people in. But sometimes it does not matter what order. So this example, how many different ways can you purchase 3 cheeses from a selection of 10? So if I'm in Wegmans and there's 10 cheeses there that I'm looking at and I pick 3 of them, if I pick cheddar cheese, it doesn't matter if I pick it first out of the group or second out of the group. It's still the same group of 3 cheeses. Okay, so in a combination, the order does not matter. this is the formula for a combination. So again, there are 10 different cheeses, and I am picking 3 of them, and the C means it's a combination. Order does not matter. So again, we're going to use the calculator here, okay? Out of 10 choices, I want a combination of 3 of them. So there's 120 different combinations of cheeses that I could pick out of that group of 10.